Good morning, good afternoon, or good evening, depending on where you are in the world today. Welcome to today's DevOps and SecurityBoulevard.com webinar brought to you by Techstrong and Synopsys. My name is Jared Harris, and I'll be your host for today's discussion. We have an exciting panel ahead of you, but before we begin, I do have a few housekeeping notes. Today's event is being recorded, so if you miss any of our discussion, or you'd like to share with a friend, the on-demand recording will be made available to you shortly after the discussion, after today's webinar concludes. You'll also have a link to access this as well. If you do have any questions during the presentation, please submit them in the Q&A tab on the right side of your screen. There's also a chat tab right next to the Q&A, right next to the Q&A tab, where we'd love for you to engage with us, engage with your fellow audience members, or just tell us where you're signing in from today. You'll also see that we have some handouts uploaded for you. Do be sure to check those out, download them, distribute them however you'd like to use them. Finally, at the conclusion of our webinar, I'll be giving away 4 $25 Amazon gift cards, so be sure to stick around through the entirety of the program to hear if you're a winner. All right, let's go ahead and kick off today's topic for achieving DevSecOps, ways to reduce AppSec noise at scale with Steven Zimmerman, developer security solutions at Synopsys. Steven, I'm going to go ahead and launch a poll. Can you give us a little bit more information about yourself and what we can expect from today's program?
Absolutely. Thanks, Jared. And thank you, everyone, for joining. First off, you'll see on your screen here a poll. Feel free to participate. Helps me understand a little bit about why you're here today, what you're hoping to get out of today's call, and helps inform my understanding of the people that find value in what I'm saying and what we put forth, where you are in your application security journey. So you'll see options on the screen here. Are you evaluating new tools or trying to consolidate with all-in-one solutions? Are you trying to be more efficient and figure out a more efficient security testing strategy? Do you have a particular problem or requirement? Maybe it's a compliance issue or an audit that you're preparing for and you're trying to get more information there, or you're just trying to learn more about AppSec in general. So take a second. I'll finish introducing myself and we'll take a look at those results. I'm Steven Zimmerman, developer security solutions at Synopsys. And as you can tell, today we're going to tackle the expansive topic of building security into DevOps with a keen eye on keeping workflows and pipelines flowing. I'm going to discuss several areas on which I recommend contributors in security, development, and DevOps, areas in which I recommend they focus. I'll take a look at the results right now if we wanted to close that poll. We'll just take a look at the results. And it looks like here today, great, yeah, many of us are looking to expand our awareness of application security, which is great. And some of us are looking to evaluate new tools as well, with a little bit of a lesser focus on trying to become more efficient or solve a particular problem. So this isn't uncommon with what I see. There's a lot of people who are trying to expand their knowledge, see what's new in the industry. And many of you are actually looking to find a new tool or a new solution. So again, maybe trying to solve a particular problem. I'll give plenty of information on each of those topics. And yeah, let's roll into this and get going. So first off, we're all trying to achieve goals. We're trying to reach an end state. Security is a goal. It's the result of our efforts and our technologies or the processes that we put in place. And security in this context is ensuring that the software that we create or that we use in our pipelines doesn't introduce new risks into production. We don't want to put our data or our customers' data at risk. And development velocity then is a goal as well. Specifically high velocity. And achieving these two goals that you see here on the screen concurrently means incorporating security without introducing more tools or requiring deviation from established DevOps workflows. And we want to have the greatest impact on business risk for our effort and time. And depending on your role, the mechanisms that you use to achieve each of these goals that you see in front of you, they might vary. But whichever mechanisms and tools you use, they need to work together. Otherwise, we just end up with, with the silos, which we all know from experience is not conducive to a goal-oriented win. And this makes sense. The goals that we talked through being focal points for security, because the surveys indicate that the vast majority of respondent organizations are knowingly pushing vulnerable code, at least occasionally, as we see here, with the plurality doing so regularly. And when we examine why this even happens, the tight timelines, that high velocity that I just mentioned, leads to pushing vulnerabilities downstream and into production. And then as you see on the right here, we've got subjective assessments of risk and the acknowledgement that, I guess in general, we just ran out of time. And right now, the plurality of organizations are using well over a dozen tools to secure their applications. And we even see a quarter of respondents surpassing 24 application security testing tools. It's astonishing. It's a lot of moving parts, and it's a lot of potential points of failure. So the biggest issues with these tools that we see kind of align to three different categories. For development, we have a lack of knowledge of how to fix issues. You see that one, they're identified here in purple. We've got security tools that don't work well with development tools. And we get low adoption of security among developers, so probably at least partially due to this poor dev tool integration. But these three reasons fit the worldview that we just talked through, right? There's a reason that these vulnerabilities are baked into our applications to begin with. And then we've got some responses that align to DevOps. A lack of integration among the security tools themselves. You've got procedural or technological friction, security scans that slow us down. We've got poor automation there on the right of those dozens of tools and mechanisms that we just mentioned. And then lastly, of course, we have, we've got the noise. We've got that unclear, unvetted, potentially inaccurate deluge of data that quickly accrues into a backlog of unresolved issues. And so we know from just a couple slides ago that these issues contribute to most organizations regularly or frequently pushing vulnerabilities into production and doing so knowingly. So for all of these tools to kind of coalesce into an efficient and effective DevSecOps program, AppSec has to evolve, or rather it has to continue to evolve. We looked at some trends that the synopsis derives from its BSIM, stands for Build Security and Maturity Model. And sampling hundreds of organizations across dozens of industries, we see that security practitioners are being deployed into DevOps teams. This makes sense. We're trying to inject security into our DevOps workflows. So let's put a person in charge of security on a DevOps team, and they'll meet once a week. Maybe they'll generate some reports, they'll push for some security practices. And among those practices is continuous security testing. If DevOps and CI/CD means moving more software assets through the pipeline, we're going to be doing more security testing. And if you've got continuous deployment, I've got continuous security testing. Of course, having a security person on an interdepartmental team, it doesn't scale very well. We constantly see organizations starting to turn to software and to scripts as a way to automate and scale security. They use what's commonly known as policy as code as a way to sustain control over these pipelines and try to do so at scale. And in order to achieve this more frequent testing at scale, we're seeing tests becoming smaller, faster, and more frequent. So for all those tools that we saw being used to fit this evolving trend for DevOps, for secure DevOps, integration has to be a clear area of interest. In fact, it's often the most important AppSec initiative that's being undertaken. We can see this here by most security and development teams today. And this is a great thing. But we all agree that automation is really the only way that AppSec's going to be able to keep up with the pace of development. Most people that we see here believe that automating application security testing throughout the SDLC can make the biggest impact on the success of the security program in aggregate. DevOps integration, it's going to reduce friction. It's going to shift security farther left. I'm sure we're all familiar with that term, shifting security left along that workflow. And that's going to help all of us identify security issues sooner. And because integration lets us extract, so the integration is going to let us both extract security risk insight and also deliver that security risk insight at various points along our pipeline. And automation's what's going to let us achieve that scalability, that efficiency, and consistency of governance that we all need in order to allay any concerns that security might not be a result of our efforts. It's one thing to, forgive me, I was operating on a different screen. Here's the supporting data to what I just talked through, automation being a critical point of scalability and integration being among the most popular areas of interest for security.
So, Stephen, really quick, can you give me a little bit more explanation on the BSIM? Is that an annual industry report, or is that just a regular survey report?
Yeah, sure thing, Jared. So the BSIM here, going back a slide or two, BSIM, the acronym builds security in maturity model. So really, it's a model to assess an organization's maturity of building security into their application development process, their DevOps workflows, their CI/CD pipelines, stuff like that. Basically, companies all around the world, across all industries, they want to know where they stand in relation to the best practices and in relation to their peers, which is one of the interesting things about the BSIM, helping people see where they stand in terms of best practices or preparation as compared to other peers in their industry. And one of the other reasons, I guess, that I find most interesting that they do this is as a form of attestation of their security practices to their customers. So we see this BSIM serving as sort of a dual internal-external purpose for organizations. So I guess to answer your question, the data points I reference here, the BSIM we generate an annual report that kind of gives some high-level takeaways that I reference here.
Thank you.
Yeah, of course. Integration and automation critical to extract and inject actionable insight or risk insight throughout those pipelines, and then automation to make it scalable. Coming back here, then we see that it's one thing to have a shared sentiment of trust across contributing teams, because again, we're talking about security development and DevOps. It's one thing to have a shared sentiment of trust, so we can all move DevSecOps forward, but we have to align all those moving parts. That's the whole part of the process for those of you here today to try and scope out a path forward to DevSecOps, or maybe trying to revamp your existing software security initiative. The people, the processes, and the technology need to be aligned so that we can achieve those three goals that I mentioned earlier, and do so consistently. Part of the issue is that what most teams have been doing so far is effectively bolting on, security onto their DevOps pipelines. They're taking legacy security products and using APIs to sort of drive them from their CI pipelines. I can't fault them for that. In some ways, our organizational structures sort of lend themselves to that. You can think of the sunk cost fallacy. We've invested in tools. We've provisioned user accounts. People have customized their email alerts and the avatar in the tool. We can't get rid of it now. So we end up with these completely separate functions that on paper should give us all we need for DevSecOps, but they lack a sort of sort of connective tissue, which we really only get with deliberate DevSecOps. So this approach generates a bunch of issues. First, as you see here, we've got some tests are manual, others are automated. So how do we achieve scale and efficiency given that disconnect? They don't have a cohesive implementation, so they're prone to breaking workflows or slowing down the build and the release pipelines. And they generate an inordinate number of results. Often, those results are contradictory or unclear with no standardization. And we end up with a DevSecOps initiative that's not really aligned from within. And this affects developers greatly because developers have their own sort of mini workflows, kind of like those that you see here, obviously a much simplified version. And these development workflows kind of exist in this superposition state that's both within and tangential to that DevOps infinity loop that we're all familiar with. They've got too many of their own development tools to run and manage, let alone anything additional as prescribed by security, which might make additional friction. They're trying to balance code quality with development speed, trying not to introduce new issues into their projects. And one dev team's stack is likely not going to match another team's. So trying to create a one-size-fits-all security pipeline is just untenable. So with continuous normalized feedback, different priorities or obscure remediation requirements can cause confusion among developers and make that scale. That's one of the reasons we're here today. Makes achieving that scale for secure development a real challenge. And of course, we end up with congested pipelines, caused by this independent AppSec testing that tends either to happen all at once, toward the end of the SDLC or the traditional SDLC as we may think of it. AppSec testing that happens all at once, or it's inefficiently sequential at the wrong point in the process. And that's leading developers, to experience, well, security and development teams to experience, vulnerability overload. More tools plus more testing equals more security issues that have to be prioritized and fixed. It's impossible to distill a manageable amount of priorities from the thousands of detected risks that we're finding per release, really. So, we have to elevate the conversation. DevSecOps isn't just about plugging tools into your CI pipeline. How do we make this better? We do this with smaller, purpose-built tests that run intelligently at the right time with situational contextual awareness. It's about each test occurring at the right time and looking for the appropriate risks, really nothing more. So I'll on the following slides, I'd like to kind of break this down into something that we can kind of procedurally talk through.
Yeah, real quick,
yeah.
Stephen, can you take a little second longer and talk about what matters the most in business? I'm sure a lot of this is going to be subjective depending on role, but how much does your role even matter, or what can we consider determining what matters most?
Sure. You're right, Jared. It's generally subjective. I think with a lot of these things in our organizations, my response to this is sort of wrapped with this understanding that we as technology professionals, we work with and work for organizations. So we've always got leadership, stakeholders, shareholders, maybe in the case of public companies, for example, they might have defined goals. We started with earlier in this webinar, we started with a discussion of goals, velocity, security, et cetera. And sometimes the process is defined or success criteria is defined for us, and milestones might be defined for us. So working toward those, we may consider in those situations, best or what matter most for the business. And I expect that a lot of people in attendance on today's call have a hand in defining those milestones or that success criteria through their respective lenses or the roles, as you mentioned, for security and DevOps and whatnot. So I guess to try and answer the question about what to consider, what matters most with that context, considering the efficiency and efficacy of a path that we define, and I'll get to that in a minute, considering the resiliency of that path, there is its resistance to change or entropy that might disrupt it, considering needs and goals of other people. So yeah, all of this might vary, based on the business unit we're in. All of this may vary based on the business unit that we're in. It may vary depending on the application that's being deployed. Is it internal? Is it external? Does it touch sensitive customer data or internal data? Things like that. Those are all factors that we have to consider, when we determine what matters most.
Thank you.
Yeah, cool. Happy to talk through that. So to kind of define a path forward, based on what Jared and I just talked through, we've got this panoply of application security testing tools that we can integrate into pipelines. Some can easily be automated, scanning activities like SAST, static analysis, SCA, maybe think of that as open source risk analysis, IAST, other types of tests, other activities have to be completed or tracked to ensure proper governance. And those usually tend to be manual in nature. Things like threat modeling, manual code review, pen testing. And it's not uncommon for these to be so manual that we're tracking them in spreadsheets, let alone integrating into an automated DevOps workflow. So our ability to get all of this done in the smoothest way possible is limited by how much security, development, and DevOps teams are sidelined by complexity, by performance issues, by noisy results. So we have to focus in 4 main areas, just to kind of help you break this down. We've got velocity, meaning that we run just enough tests to meet security and risk needs without slowing things down. And this includes that integration and automation, that shift left that we talked about, fixing issues faster, lowering cost of remediation. And ultimately, that's going to help what I call efficient efficacy. So that's performing our tests quickly when they are necessary to run, and closing that DevOps feedback loop from dev to security and back again with the shortest lead time. And not only does that need to happen quickly, but we need to focus on the other half of this term, efficacy, as well, and eliminate the risks that, going back to our definition, the risks that matter most to our project and to our business. So this means, of course, prioritization, triage, and we have to take the context into consideration with each of those. Security enablement. This is a fun one, near and dear to my heart on the developer security side. This means establishing security standards and fostering security risk awareness and risk management best practices across that pipeline and across functional roles. A developer's role may not strictly be tied to security, but through their role, they have a direct impact on the security risk posture of their project or the organization. They need insight into risks, and then they need help understanding how to fix an issue that entered a project inadvertently in the first place. And they need all of that as part of their workflow without additional steps or tools that might adversely affect these first 2 areas that we've discussed. And then, of course, lastly, we've got scale, right? This is going to include or really even require the use of sort of modular AST, application security testing tools that can be employed based on application or environmental context. So remember that pipeline congestion issue, that rotary that was just full of cars, full of vulnerabilities and issues in our case. Part of that comes from running unnecessary tests or duplicating efforts. So since we're trying to engender security into DevOps, I'll kind of build this out, this sort of path toward that scalable DevSecOps, as I mentioned. We need to define policies up front that kind of define how security testing should work. That way, the various automated DevOps pipeline scripts do their thing. Critical steps for security can occur automatically based on that. And in this diagram, we've incorporated 3 mechanisms, which I'll show you here in a moment, that have to be present in order to achieve this. Those 3 mechanisms that are critical to this whole efficient, effective DevSecOps program includes, let's see, one that allows for intelligent security orchestration. And then below that on the left-hand side, one that helps developers find and fix issues in their projects as they're writing code. And then drawing your attention to the right, one that helps co-locate, correlate, and manage data that comes from various sources. In that first mechanism on the top left, we're trying to minimize friction or impediment to the DevOps workflow while maximizing our impact on business risk posture. So this is going to rely very heavily on those policies, particularly 2 categories of policies, if I had to break them apart. We've got pre-scan policies, which help to ensure that the right tests run at the right time, as I've said here today. And here you can be really selective about the tests that you run. If all you've added in a dev sprint is an open source dependency, then why run static analysis? Why run SAST? If you've only modified proprietary code and you haven't touched any of those dependencies or those open source components, then why run SCA? Why do an open source analysis? So this is going to help address that pipeline congestion issue with the pre-scan policies. And then the post-scan policies, those help to kind of accomplish what many of us are probably more familiar with. Security gates, right? Breaking a build, blocking promotion to a repo or to staging, opening a Jira ticket, things like that. So yeah, and then we elevate our risk management capabilities with something now on the right-hand side, I think as you're looking at it, that consolidates findings from automated and manual tests into a single place. We're going to remove the noise, and we're going to be left with a smaller set of high priority issues. This is going to help address that second issue, that vulnerability overload with the gentleman sleeping on his desk that you saw earlier. And we're going to do this by correlating data from those automated and manual tests. And I've given some examples with the green and gray at the bottom of your screen there. We've got those occurring at different points in our DevOps workflow. And this is where the results deduplication is going to occur. We'll accomplish verification of risk, to eliminate false positives. We'll perform some level of triage to eliminate risks that don't manifest in the context of the application or the environment. Maybe there's a vulnerable file that exists during a development workflow, but that file is never built or invoked in a running state. We don't need to focus on those per se for production applications and taking these into consideration. All of that's reflected in that now in the top right or bottom right bi-directional ticketing system, so that we have one source of truth for real risks and risks which have been mitigated or resolved. And we do this for all those tests. I guess, before we move on, and break this down farther and get to the solution side for those of you who are evaluating new solutions, because this is a DevOps infinity loop, fostering secure development now on that left side is something that begins and never ends. We're extracting insight that we gather from our testing, and then after it's been automatically cleansed of noisy or distracting results, we then feed that back, that clean, prioritized insight directly into the hands of the developer within their IDE and within their ticketing systems and other development tools or workflows that they're already using. So we're putting information directly into the hands of people who are really tasked with fixing the issues or precluding them to begin with, ideally. And we're not going to make them chase that data down. That's a really important point. We're not going to make them chase this information down, because that's going to slow our DevSecOps down. And we're not making them question its relevance. we're doing this while maintaining that oversight and control on the security side of the house. So we're not just shifting all security requirements on a development, we're doing so in tandem with security and development. Ultimately, what we're doing is we're making DevSecOps kind of this synergistic flow of clear, contextual, prioritized insight. You can kind of think of it as taking pressure off the coding stage, taking pressure off of testing with policies, and taking pressure off of the triage stage. So yeah, let's break this down part by part, and we'll get into kind of the tools and mechanisms for those of you interested in the technology. This may still be a little bit ethereal for some of us to envision how to implement this into the business. So let's kind of break down that how. To fit the model that we just walked through, we're first going to address that vulnerability overload. To do this, we have to keep developers from engaging in extraneous workflows outside the development workflows that they're already plugged into. And moreover, we need to realize that, I heard it once stated as, the least impactful vulnerabilities are the ones that never even make it into the main project, or the ones that don't get pushed downstream. So in terms of a closed loop security program, the tightest security loop is writing code and hitting save. We can't make it any smaller than that. That's predicated on us writing or implementing secure code. So we're going to shift security as far left as possible to the developer desktop. This means using tools like in this example, Synopsys Code Site, an IDE plugin that is basically going to test both customer proprietary code and open source dependencies for quality and security issues. We're going to do this while the developer's coding in their preferred IDE. So we align these risks to policies that we talk about and standardized risk scoring, CVE, CVSS scoring, so that we can fix the highest priority issues first before the developer pushes anything downstream. In order to do this effectively, we need to give developers detailed remediation guidance as well to help them if they don't know how to fix the issue. Again, these issues entered the code base for some reason. Maybe it's a lack of developer security awareness or skill, but we're going to try and help curb that and improve that. So ideally, this is going to engender coding security best practices that help foster more security conscious and security capable developers over time. This can serve as sort of a secondary or supporting mechanism for reducing that vulnerability backlog, and also reduce the burden on security teams later on down the line with fewer issues. Ideally that would make it to them, fewer issues to review and to prioritize when security gets their hands on it. Concurrently with developer security enablement, we're going to address that whole pipeline congestion issue by running the right tests at the right time at the right level. The example I give here is with Synopsys Intelligent Orchestration. We're going to orchestrate all of those potentially dozens of application security testing tools that we mentioned. We're going to orchestrate all of that with one source of record that accounts for the policies that we've defined, the distinct profile of the application, and understanding what's changed in a particular sprint so that we only run those appropriate tests, like I mentioned, to find and fix the new issues that were introduced. This includes those automated tests as well as those manual activities, so we don't need to worry about that. And this is going to allow us to establish security without slowing down the pipeline, because security is going to connect to our DevOps workflow while also kind of running parallel to it. So we extract and deliver relevant insight at critical points, but we're not going to get in the way of anything, at least unless we've configured a policy that requires that. And we'll still be able to take those defined actions and establish that those deliberate security gates wherever we might need them. And then the third aspect of this, we're going to try. It's kind of an interesting topic here with the functional security tests. You can see here in the subtitle. We're going to try and get more testing without running more tests. So In this example, we're going to do this with interactive application security testing, or IAST, I guess is the acronym there. Example I give is Seeker. You might be familiar with IAST already. You may not be. In essence, it's kind of like, it's basically gray box testing, or kind of like having a team of virtual pen testers, except they're available 24/7. They're more accurate and way faster. So that's kind of what an IAST solution is. So we'll plug our IAST tool into our CI/CD pipeline. And all the functional testing that we're already doing, we're already performing functional testing as part of our workflows. We're going to transform those into very precise security testing automatically without any extra effort, or I should say no extraneous effort outside our standard workflow, outside that standard functional testing. So what's cool about this, we're able to layer on automated security risk analysis on top of both those automated and those manual functional tests. So this approach is going to do a few things. I have them listed here, right? It's going to enhance our ability to detect vulnerabilities that might have been missed with that, other types of earlier testing. Those vulnerabilities that only manifest in runtime. That's an example here. Where we'll detect vulnerabilities that manifest at runtime that may have been overlooked with static analysis, or maybe in absence of a vulnerable open source component or things like that. This also means that we're more capable of detecting risks that are ingested through the software supply chain. That's another topic, another hot button issue today. I encourage you to do a little more reading as well. On the software supply chain, we've got some good resources for that as well. But these supply chain issues are the ones that maybe we had no source code to analyze earlier at all. Or maybe it's software that's composed of secure vulnerability-free components, but maybe it contains malicious artifacts. And that's going to be detectable here as we securely analyze this during these functional tests. And it's going to enhance our ability to support data protection, compliance like PCI, HIPAA, GDPR, things like that. This pre-production testing, so again, this is pre-production testing during your functional tests. This is going to let us see what's executed when, what data is transmitted or accessed during those processes, which tools are invoked, or rather, which protocols are invoked. We'll apply this policy-based approach to AppSec that I mentioned earlier. We're going to apply that here, but we're going to apply that policy-based approach to sensitive data leakage. So we can define parameters and patterns for what sensitive data even looks like in the context of our systems or applications being tested, and we'll identify potential risks to that data. So we're going to do this for all of our web apps, all of our web APIs, all of our serverless functions, microservices, containers. And one really important thing, I guess, before I close out this slide, one really important thing to know about IAST using Seeker in this example, it goes back to a core tenet of this webinar, reducing the noise. I don't want to lose sight of that. Making more informed decisions for risk prioritization and remediation. With this approach, our IAST tool is, it's going to automatically retest detected vulnerabilities. So we're not only verifying that they're real, but also that they can be exploited. So this means that we're getting that clear list of exploitable issues with near zero false positives, so that any triage that we're doing here, it's going to be based on real verified risks. So yeah, as this functional security testing occurs continuously as part of our pre-production testing cycles, we get this real-time data that we can then add into our collection of risk insight. And it would be completely reasonable if you asked, if you asked me right now, like, we're already time crunched. We talked about, getting things out the door. We're not adding more security testing tools. Why add more pre-release testing? And that's ideally answered by our fourth topical area here. We need to manage this insight better. That's a critical aspect of this, because more insight can be helpful if it's managed appropriately and also kind of pared down for actionability. So we're going to add this insight management, to this new iteration of our security program. And we're going to manage all the insight that we get from those various tests and tools with an insight management tool that's going to normalize and correlate findings. Those are two very important aspects here. It's not just collecting data, but we're correlating it as well, so that we can make those better prioritized decisions for efficacy. So something like Synopsys Code DX here, it's going to automate the resource and time-intensive process of triage and prioritization. This is way more than maybe you're more familiar with, say, a Splunk dashboard of data. It's not a BI tool that's just co-locating results. We're using this as a singular system of record for all of our application security risks. So that's everything from the manual reviews and bug bounties, our source code and our open source, our automated, our manual tests, network vulnerability assessments, all of that here. So that's going to let us optimize what we do with the data that we do collect, and really lets us do things. I've got a few examples on the right here. We correlate and dedupe almost 16,000 findings down to 8,400 unique findings. We assess the impact of security testing across all of our tools. It's not just tools from the same vendor. It's not just Synopsys tools in this example. It's exploitable vulnerabilities that, it's all of our testing feeding into this one place. And we can minimize wasted efforts by identifying overlapping tests and duplicative results. My favorite thing on the screen might be hard to identify here, but we can identify just the 51 exploitable vulnerabilities that make us non-compliant with PCI regulations. Let's fix those first, right? So all of this makes our insight less noisy and more actionable, so that we never lose control over that synergistic DevSecOps loop. I'll call back to this path, because we kind of dug several layers deep here. This sort of path toward DevSecOps are the three critical areas of focus, layered on with the various testing tools at the right place and the right time. My recommendation is also a reminder of what we discussed before. Intelligent, policy-driven DevSecOps. It's not bolted on functions or applying modern best practices to legacy security tools. The way to kind of walk through it, it's defining pre-scan and post-scan policies that understand the context of the environment and the application that we're analyzing. We're going to run the right tests at the right time to collect risk insight or risk information that we're automatically verifying and cleansing, so that we can then send only the most impactful priorities back to the development teams for remediation. While we're doing this, we're investing in making our developers more security aware and more security capable, so that this DevSecOps loop itself becomes more secure over time. That's, I know we had a dense conversation, but Jared, I'd love to hear if there's any questions in chat.
Yeah, so let me see here. One of the questions we got is, since most companies use a lot of tools already, is there any way to consolidate them or use the data better?
Yes. I think, it's a reasonable question. After, I spent some time today talking through the different tools and tests, some of which you might already be using, but if you're not using some of them already, it just seems like we might be adding to that tool fatigue. A lot of the organizations that we work with, especially the larger enterprises and those that grow maybe through acquisition, you just inherit these tools over time. Maybe the owner of the tool, the person that brought it in, saw value of it, championed for it. Maybe things get lost in bureaucracy or auto renewals, and we just lose sight of all the tools that we accrue over time. So I guess the first thing I would say is there's a likely chance that you've got tools that are performing duplicative tests. Kind of talked through that on that last screen. So surveying the landscape, the tools and technology across your organization. That's step one for consolidation there. And then I guess the other half of that, which you can do while doing that tool assessment, seeing where you've got duplicative tools or duplicative results, redundant results. Just make better prioritization and triage decisions for remediation, right? That is using the data better based on your question there. So that ideally we're going to automate that feedback loop for developers so that they know, so that the developers know the best way or the right way to fix that. Because we see a lot of AppSec initiatives fall down when there's this buzzword-based shift toward DevOps, but there's a woefully underemphasized focus on closing that security gap in development. So that's what I would say.
Then we've got, does CodeDX correlate vulnerabilities coming from SAST, DSAT, and CSA?
Yeah, thank you for that. I would say, I guess I should preface this just in case my definition of correlation varies, across your area. So CodeDX, yes, is able to ingest data from a wealth of different types of testing technologies and tools from a bunch of different vendors. And so multiple SAST tools, multiple SCA tools. I think DAST may be in there. That's the one that I might put a little asterisk next to. I believe it can, but I would certainly check the CodeDX documentation on that. But yeah, that's the purpose of something like CodeDX to ingest that data. And I'll walk it back here a slide or two. And so I think in this example, you can kind of even see, it might be a little bit small for you to read, but just to the right of that black framed image, you see a smaller box that says tool. And there you can kind of see the various tools or vendors that you're using for those tools, the number of percentage of results that are detected by it. Just to the right of that, on the furthest rightmost side of your screen, tool overlaps. That's where you see the overlaps in tools. That's where we can start digging into making ourselves more efficient and potentially even saving money or effort with managing multiple tools that are giving us redundant results. So hopefully that answers your question.
And at some point you said something about being able to do your own local testing as I code. How does this work with the security team since they handle your testing and plan?
Yeah. Yes. So local testing. So I guess if you're on the development side, right? I imagine on the development side is where we're coming from here with the local testing as I code. For anyone else here on the security side of the house, don't worry. This type of a question is a good thing. We want that shift left mentality for security, and we consistently see that security tools effectiveness or adoption of those security tools really heavily depends on whether or not developers can easily get value from it. So it's definitely possible for security to configure those pre and post scan policies that I mentioned earlier and establish automated security gates while we give developers, while developers kind of focus on their own role in secure development. And so a lot of security tools are starting to realize this developer influence on security. Synopsys, for example, we've got an IDE plugin that lets developers test their projects as they code it, as they write it, almost like a spell checker for code, I guess, if you're thinking of it that way, like a spell checker in word processing. An IDE plugin here that kind of performs static analysis or analyzes open source components for security. So say your developer's writing code, maybe you're writing insecurely, you've forgotten to set a timeout, you've left yourself open to cross-site scripting attacks, SQL injection. You can see that, right there in the IDE, you can see that you're bringing in a vulnerable open source library, and then you can see the next version that doesn't have any vulnerabilities. So you can kind of bake that in from the start, rather than having to wait to fail a security test later on down the line and perform rework the night before you're supposed to, end your sprint. So yeah, you can definitely try out CodeSite. I know that we have I think we got a trial for the CodeSite IDE plugin on IntelliJ and VS Code. We've got some trials there, but yeah, basically the answer to your question here is looking for an IDE security plugin that helps developers kind of toe that line for security.
So we've got one more question, and if anybody else has any more, we've got some time. So let us know, while he's answering this last question, what you want to know. So the last one we've got is, how do most companies you work with go about restructuring our plan to a new software or security program?
Mm-hmm. Yeah, I think, yet another subjective topic, Jared. But maybe, maybe what to help you, what I would say is that you're not alone, in having this vision of DevSecOps kind of obscured. I think I would kind of put it into a couple of categories, right? We see that we see companies that have established tools. You've got established tools, you're trying to improve reporting, maybe you're trying to improve integration, you've got Slack and Jira integration, you're trying to automate breaking a build, or if something has a critical severity vulnerability, you take certain automated actions, for example. But again, these things lack that deliberate approach to that efficient efficacy that I mentioned before. So that's one side. That they tend to slow down over time. That type of organization taking that approach to their security program, they tend to slow down over time, if not almost immediately, when you hit save on those automated triggered actions that could negatively impact the pipeline. The other type of organizations that we see, I guess would say, are the ones that are they're using the organizational change, they're using the investment landscape or other inspirations, to start fresh. They tend to pursue what analysts or industry influencers prescribe as best practices. This does let them structure a program from the ground up, but that could be a lengthy process, could be a bit ethereal. It involves a lot of stakeholders and a lot of teams, and it can be sluggish to make progress, or hard to get maybe executive sponsorship for something that might seem, at least at a surface level, hard to implement, with this kind of persistent lingering doubt that it might even be better than what we already have. So I guess I would say wherever you fit on that spectrum, having those the recommendations here for going about that restructuring or planning, have those cross-team discussions about success criteria. That's one. How do we know when we're done and when we've done it correctly? Assess your tool portfolio. That kind of goes back to that Code DX question we got, for example, and finding those duplicative tests and results. Identify security gaps, because you may not be doing all the testing possible to find all vulnerabilities, or again, you might be missing that opportunity to turn functional tests into security tests. And then identify inefficiencies or opportunities for greater efficiency. So having those conversations is necessary, because none of us can drive this individually. It's just the nature of our tech stack and of our organizations nowadays. So once you have those conversations, then we see people move to that next phase, optimizing your toolbox, your solution vendor relationships, restructuring mechanisms used to measure security or measure performance and success, and then pushing internally for security awareness is the last piece of what we see a successful kind of shift doing. And that can happen concurrently with restructuring those tools, because you're probably going to have some level of training or re-education or something like that to kind of help people wrap their head around this new process.
All right, I don't see any more questions at the moment. So unless you have any final notes, we can close out.
No, yeah, I think I'll leave you. I'll leave you here. We've made it through a rather dense conversation in a pretty tight time frame. I thank all of you for sticking with me today. As always, as you'd expect, you can get more additional information. We have some handouts here associated with this webinar if you're with us live today. And you can always visit synopsys.com/software-integrity to learn more about DevSecOps and some of the tools that I mentioned today.
All right, that was an outstanding presentation today, Stephen. Thank you for giving us that discussion and all of your expertise. Just a quick reminder for everyone who is on the session today, this is recorded. Following this panel, you will receive an email with a link to access the recording on demand. In case you don't get that, it goes to your spam, or something happens, you can always go to our website, devops.com or securityboulevard.com/webinars, where you can find it there and rewatch it again. As I mentioned at the beginning of the program, there will be 4 gift card winners. I want to go ahead and mention those are for Darwin M, Georgia P, Maria M, and Somni F. Congratulations to the 4 of you. Please keep an eye on your inbox where you can claim your gift card. Make sure that you also check your spam. An email does happen to show up in there from time to time. Steve, again, I want to thank you for taking the time to be with us. I'd also like to thank Synopsys for sponsoring today's webinar. I also want to thank each of our audience members for taking the time out of your day and being with us for the entirety of the presentation. Again, thank you. There will be a short survey that follows up with this presentation. If you don't mind, just take a few moments, answer those. We'd love to hear from you, and let us know what we can do to improve on our next one. We'll talk to you soon. Have a great day.